Class, the other new, somewhat confusing topic that we covered so far in general chemistry is the concept of average atomic weight. If you look at the periodic table, you'll see weight of the various elements. The weights of the various elements are not a whole number because they are a weighted of all of the various isotopes. We'll get to this problem in a moment. Carbon 12 has a weight of U, NO carbon 14 AMU. On the periodic table, what is the weight of carbon? 12.011 AMU. Why the discrepancy? The discrepancy comes from this is the weighted average of all of the various carbon. Okay, little side note, set this in brackets right here. This is a side note. Let's look at the problem at hand. It says an element has two stable isotopes, 35 AMU, 75.78%, and 37 AMU, 24.22%. Calculate the average atomic weight and identify the element. So first I want to talk about the ways to calculate an average. So the way most people think about calculating an average is the mean. So mean says you take the sum of n, and let's say, it's x to the n, and then you divide by n, which is the number of values you added up. This is equal to your mean, otherwise known as x with a bar over it. In this particular problem, we need the weighted average. So in order to calculate the weighted average, you want to do another summation of n, percent n times, let's say, your weight or your atomic weight n. So sum up all of your atomic weights multiplied by their relative percentage, and this will give you, this equals the weighted average. So it is this weighted average formula, I'll put a star by it, that we need for this particular problem. Okay, so we have 35 AMU. So if we take 35 AMU times, what is it? 75.78. So 0.7578 plus the other is 37 AMU times, what would it be? 0.22%. 22%. So it would be, 0.2422, 0.2422. Now we do the calculation. So it is 35 times 0.7578 plus 37 times 0.2422. What does that equal? 35.48. 35.48 AMUs. I'll go ahead and highlight. So this is the average atomic weight. So equals the average atomic weight. And now, what is the element? If you go to the periodic table, I'm not going to display one right here. 35.48 0.48. What might that be? Oh, closest element is chlorine, which is 35.453. So I would say, lo and behold, this particular element must be a chlorine. If the element you're trying to find the weighted average of has more than two stable isotopes, then you would have more than two percentages and more than two isotopes to add up together, but the procedure would be exactly the same.